Hello my friend, welcome in this new recording. Today we will talk about the image-based lighting in the previously implemented physically based rendering pipeline. So yeah, this was a pretty tricky extension that I've been working on for a couple of days at least. And there's probably a lot to cover to give you an acceptable overview of what this is exactly. So, yes, I'm pretty sure this recording is going to be a somewhat long one. And my idea is I'm going to cut that into different pieces. So, trying to keep each piece something like 25 or 30 minutes, not more than that. And we'll see if we need multiple pieces together to cover the complete devlog that I did on this topic. So yes, let's try to jump into it. First thing I think I should do is try to show you what we have implemented, what is the final result. So I've been working on this file only, the PBR IBL. So IBL is for image-based lighting, and we can just run that as another example in my project. So it's already built, so you have the latest changes and everything in this demonstration here. And what we have here is similar to the previous one. So the previous one was the PBR basic example. So it's similar, but we have added support for the environment lighting. So I'm not sure I can really explain that clearly, but what we have with this image-based lighting concept is you have an object and you can use PBR to control how this object is going to display. So for each fragment or each pixel that you're computing and where you have this object, you can use material properties from this object to figure out how it's going to react to light. And so you can have different lights in your scene lighting this object, but you also have an environment around your object. And with IBL, the idea is you can use a cube map representing the environment around your object, and you could kind of think that every single pixel in this cube map is giving you an indication of what is the light received from this environment coming from that direction. So you can imagine that every single pixel is a light source in the cube map around the object. And starting from this point, you can actually pre-compute quite a lot of stuff, and you will end up with an efficient mechanism to get the final result for every pixel on your object. So you would have, for instance, on the sphere here, you could take any pixel on the sphere, and for that pixel, you would compute the contribution of all the light directions from the environment that are reaching this pixel. And this will define what is going to be the diffuse color of the pixel, and also the specular color, depending on the metallic aspect of the object itself. So pretty tricky to understand it all, but that's the idea. So you're using the environment cube map to try to change the display of the object. And what we can still do here is you can already see that it's not exactly, maybe if you remember the previous example, it's not exactly displaying the same way because we have kind of small bluish color above and a bit more grayish color at the bottom. This is somehow reflecting a bit that we have blue here in the environment and gray at the bottom. And we can make still the surface more or less metallic. And so if you remove the metalness, you see that it's not really displaying this effect anymore. But here you have this blue display, and if you reduce the roughness, that's where you can start seeing really significant changes, because now you can indeed see the environment map applied on the object. And yeah, so this is it. I can still move around, and for instance, here you would get a perfectly metallic and non-rough surface, so perfect mirror, and you see that you get the environment display very precisely. And if you try to increase the roughness, you will progressively see the change on the display. Okay, so we can still do the same thing, change that to gold, for instance, and play around with the settings here. And yeah, the main addition was really the support for displaying this environment map around it and integrating that into the PBR computation. So yeah, this is it for the overview of what we're going to achieve, and now we should go maybe into some of the details. So let's stop this for now. And as usual, I've been writing a small article along the process when I was implementing this example for the image-based lighting. And we are going to go through this article actually and try to follow a bit the process of thinking and try to give some details. What I need to mention first maybe is this list of references. I've been collecting those pages progressively when I was working on different points here, but yeah, I've provided them all at the start of the article, but well, you probably want to have a look at this if you are interested in understanding more of the details. So this one, the shading language specification, this is a core file for web GPU. So this is something you probably want to keep up in whenever you're writing WGSL, because if you're not used to it, you have references on all the functions and well, everything you can do in WGSL, it's described here. For instance, at some point I was looking for how you can sample a texture with specification of the level of details you want, so the map level that you want. And if you come here, you can try to search, for instance, for, I don't know, there's the texture sample function. And if you look for this one, you will get a list of built-in texture functions here. And there is, for instance, the first one here, but there's also this one, texture sample level. And yeah, the documentation is not very explicit all the time, but it's enough to understand what you need to do and how you should write your function call. So that's most of the time all you need. Okay, so this one is important. This one is a generic specification on web GPU. I have not really mentioned that before, but again, this is, well, a critical one, and you probably want to refer to this one very often when you have doubts and you need to get information on some functions. And the other pages then were more about what is PBR and what is IBL specifically. An interesting one, in fact, I mean, most of them, if I kept them in this list, it means that I found that they were interesting at the time I was implementing this. So maybe we should just give it a review. Yeah, this was for the implementation of the random function. Okay, not that critical, but interesting to read. This one for another function that we use when we do the building of all the texture that you need for IBL. And this is used to send you, well, to sample different direction in your hemisphere, in fact. Ensuring that your samples are properly distributed. I don't want to go into too much detail because anyway, I don't really know too much of the details. I just know that this is a different kind of sampling method to distribute your sampling directions. Oh, okay, I need to plug my camera on power. Okay, so this is interesting. I just realized that my Fujifilm X-T4 camera can get very high. Temperature of the camera can get very high, and this is apparently due to using the battery of the camera itself. So I've now plugged a cable to provide power externally, so I hope that the temperature would stabilize. We'll see. Anyway, what was I saying? What else do we have? This one is also an interesting one. It's describing a bit what has been done. No, that's not the one I was thinking about. I remember seeing the... Nope. I mean, it's related to what I had in mind, but these are not notes. This is the initial implementation that I've been using as reference from the Web GPU native symbols repository on GitHub. So you definitely want to check this repository also because it's providing, well, a lot of different examples, and this is the one I'm using currently, in fact, to get well, references on how to implement anything with Web GPU. Except that this repository is implementing everything in C, so I'm making the change myself to try to move everything to C++. What else? Next, also this page here, Learn OpenGL, is very interesting. In fact, those two pages, they are the most important one, I think, where I learned what PBR is and what the IBL is exactly, and how you should prepare everything to work with those. So yes, more reading here about the theory and what are your surfaces and all. But it's definitely worth it. Okay, so those two pages. What else? This one is another example. This one is PBR in Web GPU, but the JavaScript implementation. So not really useful for us here because we're going to do everything in C++, so I didn't really use this one. And yeah, so you could check maybe the other ones and you'll see. Anyway, when it comes to image-based lighting, there are basically three important pre-computation things or elements to do. So the first one is this BRDF 2D lookup table that is to be computed. Let's just quickly have a look at the second one maybe. Second one is going to be the computation of the irradiance cube map. I'm not quite sure myself what irradiance is in this context. I mean, it's the quantity of light. So what you're doing here is, yes, I think I kind of remember, for every direction that you could be looking at, so you're generating a cube map at the end. So you could have any direction around a center point. So for every direction like that, you are going to consider what are all the contribution of the light in the hemisphere where your current normal, your current pointing direction is the center of. Wow, come on, that's an interesting sentence. So you add a direction and you consider all the hemisphere that you can see. Basically, it's like if you're on the Earth and you have your normal direction, which is pointing up locally, and you look at everything that is above the horizon. You consider all the direction on this hemisphere, and you take the contribution of the light in every direction. And you basically sum all those contributions together to generate what is called the irradiance, as far as I understand. Anyway, we get back to this one, and then there was a final step, which was the pre-filtering of your actual environment map. This was another additional optimization step, and I actually didn't mention this page. No, I did. It's this one. And on this one, it's describing this pre-filtering of the environment map. I think you can actually do without that, but if you do without this, you need to take a lot of symbols at runtime. So not a good thing to do. You want to pre-compute that as much as possible. And yeah, this is the idea in this article. Again, a very interesting article, so you probably want to have a look at this one too. And in the end, I think the part that is important for us is this one. Yes, so we'll get back to this one also. Anyway, let's start with the BRDF precomputation. Okay, still I need to still keep an eye on the time. And let's get back to the code. What do we have here? It's basically I was starting from the previous version that we had in PBR Basic. So we're going to find some of the same elements here, probably at the end of the file. So let's start from the end. But you see that, yeah, we have quite a lot of additional content. It's still a bit long. I would like to try to optimize that to reduce it, but we'll see later. What we're doing here, we're still doing a rendering, and before that, we have the setup function here. So what we do in this setup app is we first do those 3 steps, which are the pre-computation steps. And the first one is the generation of the BRDF lookup table. And one interesting thing I could mention already is this. I've added support to be able to execute all the render passes that you have registered so far in the engine. So when I do that here, in fact, in those pre-functions, I'm going to define some render passes. And when I do the rendering here, I don't have any render pass defined yet for what I'm going to display in the actual scene, which is defined after that. So you see I have a render pass definition here. That's where I'm going to add a skybox, and that's where also I'm going to add those 2 spheres, the first one here and another one. So this render pass itself is not defined yet, but you can still request a rendering of all the existing render paths, so it will effectively perform the computation that you need for the generation of those additional inputs, because you need the textures generated by those functions as input to actually plug them into the shader that will be used to render the spheres. So on the spheres, we're using this new shader, the PBR IBL, and it's going to use, as I said, those 3 textures. So there's a filtered environment texture, which is the last one. There is the BRDF texture, which is the first one we need to check, and the irradiance texture, which is the second one. Okay, so let's maybe have a look at the BRDF lookup table generation, and trying to follow what I kept in the notes here. So I added a show texture program. Yes, because basically this one is going to be a 2D texture, so I thought before I tried to generate anything, it would be good to have the possibility to kind of display a 2D texture as an additional view on my scene. So you just, this shader here, basically just take an input to texture and just output that onto a quad, which is aligned on the screen. I think, yes, it's just taking a vertex index, in fact. And it's drawing that with 3 vertices. So it's using this, yeah, you know, use this trick where we actually display a triangle to cover the screen. So you have to make the triangle bigger than the screen, and you're actually clipping part of it due to the clipping space. But since I'm actually not rendering to the full screen, but I only want to reduce that to a small part, I had to be a bit clever about that and try to manually clip the triangle, because otherwise you get a triangle shape. But yeah, if you do that, you can just keep using 3 points and display a small quad on your main screen. So this was just an helper script, helper shader, not really critical, I would say. What else did we have? Yeah, there were a couple of functions here that I need to discuss. Yeah, at some point I had an issue with those functions because you can actually find 2 different versions of them. And I thought that maybe it was just an evolution of the first one and then you would reach the second one. But yeah, I eventually figured it out that it's not the case. You have 2 different versions because you have to use either the direct one or the IBL specific one, depending on what you are computing. And this is described again on this page, so the Learn OpenGL page. Boom, 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 boom. I think I can't find that. Or maybe not. Yeah, that's the part. If you recall, blah, 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 blah. So you have 2 different versions of the K is the roughness here, right? Oh, alpha is the roughness. No, K is not the roughness. Alpha is the roughness. All right. Anyway, not a big deal. Just see fixed render attachment format. Okay. What was it about? Actually, I added quite a few issues because I was still in the process of building this whole engine and the render pass concept and so on. So yeah, what's not really working. For instance, when I was trying at first, I was trying to generate float textures because I thought, yeah, that would make sense. If you want to produce a lookup table, you probably want to have float values in those table. So yeah, I try to use RG32 float as a format, but if you use the float32 format in WebGPU, you get quite additional issues because as I said here, in fact, lesson 1 that I learned is that those textures are not filterable, so you can't actually apply linear filtering, or actually even nearest filtering is not working. You have to explicitly disable the filtering completely when you're setting up your pipeline. So I have been working on the mechanism that I use in the render pass to support for that, so that when you are using a float 32 render texture, you would disable the filtering and yeah, take a few additional stuff like that into consideration. Anyway, let's maybe get back to the code and try to see if it's easier to work from here. This, in fact, is not very complex because to generate the BRDF lookup table, you don't actually need any kind of input, and the shader can work on its own. So you just provide a target texture, and this is what I'm doing here with this render RTT pass. RTT is for render to texture, and this will generate a render pass, a regular render pass in fact, but with some custom settings. And the settings that I'm using here will build a dedicated texture by default and use that texture as a render target. Let's not go into too much detail about that because otherwise we're going to spend the day on this. But yeah, it's going to call render pass. Render pass here is going to create a render pass object with the proper description. And when you reach then the construction for the render pass, you will figure out, okay, you are either targeting a swap chain, or maybe you want to do a render to texture, and if it's the case, then you may need to create an actual texture to render to. But yeah, not necessarily, in fact, because we can also provide an existing texture which we want to reuse, for instance. So you could have created that texture outside of the render pass, and you just want to use that as a target for another new render pass. So this could be provided here with a target texture. And yeah, you do the same thing, in fact. Well, you don't do exactly the same thing for the dev attachment. I don't think. For dev attachment, I'm always creating a new texture, not really using an existing one yet. This could be extended later, but yeah, there was no need for that so far, so not implemented. Anyway, what we could have a look maybe is the shader itself, gen BRDF LUT. So this one, what is going to do is you start with texture coordinates, basically covering your complete target texture, and you compute this BRDF function call. So this part is coming on, well, directly from the existing web GPU native symbols repository, and we are almost at 30 minutes, so I need to somehow get this. Let me see. Let's just have a look at the previous one. So PBR, that's for the basic one. IBL. This one was the one I was using as reference for this implementation of the BRDF lookup generation. And you see we're doing the same thing here, except that this is GLSL, and this I had converted this code into WGSL. But yeah, I didn't change anything in the logic itself. So we have this BRDF function, and it's using some of those additional helper functions. Except that all those helper functions here are defined in the same file. But in my case, since I have support for pre-processing in my shader files, I could actually put them in a common file. So this is what we're doing. We only have the BRDF function in this file here, but we are including the base utils, and that's where we have the additional PBR related helper functions. So you will find them all here. And as I said, I had to support both versions of this function, so I use the prefix here because also another thing is, well, you have the same signature, so it would not work here. But anyway, in WGSL, you cannot use function overloading as far as I remember. Not yet, at least. So you need to explicitly use different name for the functions if you have different arguments, for instance. But this was not the case anyway. And okay, so this is the first part of the processing. We're not even done with the BRDF LUT generation, but yeah, I'm going to cut the recording and we're going to continue with a second part, because otherwise I'm going to generate way too long videos anyway. So yeah, see you in part 2. Bye bye.